Hi, so it's Tampere. That's where I live.
Thank you.
When I was naming this presentation, I first thought of naming it IPv6-only IXPs are coming, exclamation mark. But I thought that even if this current form is also too controversial, I think that would have been too controversial. So basically what you can do is, after the presentation, make up your mind yourself whether they're coming or not. But what is it all about? So basically, I think about 7 years ago, RFC 5549 specified a way to announce IPv4 routes with only IPv6 next hops over BGP. And well, vendors were a bit slow to adopt it at first, but then it started to pick up speed when big operators, VPN, who had MPLS VPN in their backbone, noticed that they can free up a lot of IP space by adopting it in their backbone. But then also when people started using it more, they found a few features in it, so it got updated a little with RFC 8950, and that's what we like to call it now, even though it's basically the same thing as RFC 5549. But yeah, the point is that you can eliminate a lot of IPv4 space on your network if you use this tech to announce all your IPv4 next hops. Basically what it means is that before you had ARP to find out the MAC address of the next hop, the next router where you send your traffic. But if your next hop is not an IPv4 address, then of course you can't do ARP. You do IPv6 neighbor discovery instead. And routers still need to have at least one IPv4 address because the routers still need to originate some IPv4 traffic. For example, path MTU discovery or traceroute, or, well, there are a bunch of other uses as well, where the router needs to send ICMP messages to whoever sent some other packet. Basically, the routers usually, in many routing protocols, also need router IDs, and the conventional way has been to use the same IP address as on the loopback for router IDs. These days, you don't necessarily always do that anymore, but you know, that's a matter of opinion. But now I'm talking about IXPs, so adopting the same tech over ISPs. And so why am I doing that? Why am I rocking the boat? All IXPs already have IPv4 addresses. And even if they don't, if you want to set up a new IXP, RIPE here in Europe has a special address assignment policy that guarantees that IXPs can still get IPv4 address space when they need it. But one reason I'm talking about this is that renumbering IXPs is painful. Links renumbered their peering LAN from a /22 to a /21 right after COVID. Anyone here, show of hands, are you a member of Links? Do you remember that? Couple of hands, yes. Before that, they renumbered about a decade earlier. Anyone here remember that too? Was it painful? It was painful. The first time they did it was already in the 1990s. Thanks Moyaz Shivji from Links for digging up the exact dates for some of these events. France-IX, Radu Adrian from France-IX told me that when they had to renumber in 2019, it took roughly 2 years before the renumbering was finally finished. So this is basically part of the pain. The problem is that typically too sizable a portion of members of IXPs are running their IXP connection, on auto. So they don't, when you tell them you need to change this configuration, they don't react. And well, you just don't want their traffic to end like that. They'll be mad if you do that. So that's why it's painful. I also looked up the last time AMS-IX renumbered. That seems to have been in 2014. So here in Amsterdam, there's also experience of this. And well, most big IXPs have renumbered. I also gave this presentation at a NetNode meeting, and I was surprised that NetNode had somehow not have to renumber yet at that point. But I hear that they also have something going on regarding renumbering in the future. So the alternative I'm proposing is, what if rather than renumbering every time you run out of space, you do one final renumbering event? And the renumbering is in quotes because it's not really a renumbering, because most of the IXP members already have an IPv6 address configured. They already have BGP sessions with others using those IPs. So all they really need to do is enable one address family on the existing IPv6 BGP sessions and tell it to use the RFC 8950 next hops, or enhanced next hops, as they're called on many router configs. And so NIX in the Czech Republic is already testing this system. They've got this Phoenix subnet, which is a subset of their members that are all committed to higher security standards. They have to implement RFC 38, which means that they have to do RPF filtering to their customers so that customers can't use spoof traffic. They have to have active abuse and knock contacts when they're tested. And there are a number of other security features that NIX members need to fulfill before they are let into the Phoenix subnet. So basically, it's the active core of NIX, or at least that's how I see it. And they are testing it on that subnet so that it only affects those members that are actually actively monitoring their connections anyway. It's easier to get feedback and develop or get around any problems cooperatively with members that are willing to talk to you about things and who are willing to implement changes. So my information on the slide is a bit older. It says 6 members are involved, 12 sessions, 128 prefixes in February. I spoke with them just earlier this week because EurIX had a meeting in Antwerp near here, and we discussed these issues there with, with all the members of EurIX. And now they have like 12 members and, 24 sessions and about 214 prefixes. So they are having more and more traffic, but they haven't ditched their IPv4 yet. This testing is just on the same subnet alongside the traditional IPv4 BGP sessions at NIX CZ. Although I heard that 2 members were turning down their IPv4 addresses or the IPv4 BGP sessions, so they are trying to sort of give a motivation for the other members to also actually adopt and start using it. TREX Tampere, my exchange point, is also testing it in a similar way in that we've got a route server that accepts and validates these routes, but we haven't actually told our membership yet. We've got a NOG meeting in Finland in a couple of weeks, and I'm going to talk about it there, and not a lot of people know about it yet. But what they do know is that we also set up an exchange point in Turku, and in there we are testing what about not having IPv4 addresses on an IXP from day one. So when we were planning the Turku exchange point, I did have a bunch of IP addresses, IPv4 addresses I thought about using there. But the problem is that if I put them there, make them available, start handing them out to members, it's going to be very difficult to get them back. So I think it's easier if it's IPv6 only from day one. So I already mentioned that RIPE has this address space assignment policy for IXPs, but just a few years ago, it was updated so that when before the IXP could get a /24, which is a nice subnet size, now the initial assignment size is a /26. So you have to renumber twice, from 26 to 25, and then from 25 to 24 before you reach that normal IXP subnet size. So for new IXPs, it can be very painful. So that is also one thing to think. So we already, at TREX Turku, we already had IP address space set up or reserved beforehand, so we didn't have to use this policy at all. But if we would have had to use the RIPE address assignment policy for Turku, we would have probably chosen to go IPv6 only even more. So, as Tim mentioned, the EURIX, the European Association for Internet Exchanges, has a working group, which I am one of the chairs of. Andre Grüneberg from B6 Berlin is another chairman. And what we set out to do a couple years ago is, well, first map out what the support for this feature is like, and then also to map out any challenges. Well, at first we thought that only the open source daemons support it, and no hardware vendors were supporting it yet. But then we noticed that surprisingly many hardware vendors were supporting it. So then we started to map out or test how they interoperate. And, well, we found some issues, but our testing wasn't very methodical. But now DECIX has hired a master's thesis student to make a methodical interoperability test between like about a dozen different implementations and build a full matrix of what works, what doesn't, what conflicts there are, and so on. And as we've been testing it, we've been filing reports, bug reports, feature requests, stuff like that. So basically, the idea is that if in a few years' time more people will actually want to start using this, the bug should be fixed by then. We want to sort of raise awareness about any problems we find. Our work is open in that there's a GitHub with a link over there where we list, we've got examples for different platforms of how you configure it, what are the important bits in the configuration, how the router behaves in different situations. Like if you make a trace route through a link like this, what address does the trace route response come from, or the ICMP error message, and so on. And also how you can affect it, how you can configure it, how it chooses the source address for the trace route error message, for example. And we're always happy to get more people involved. So if somebody wants to get involved, get in touch with me, or if you just want to autonomously make some additions into our GitHub, we do accept pull requests. We've actually gotten one pull request completely out of the blue, and well, we accepted it because it seemed okay. We've also got a mailing list and a Mattermost chat channel where we discuss these issues, and so those are what you need to contact me for. So I can get you added there. So the original RFC, as I mentioned, was mostly aimed at VPN address families. It did sort of implement normal IP transit BGP table as well, or the default free zone, but that's not what it was aimed at. And interoperability hadn't been tested much either, because most of the people using it were using it only within their own core. And now we were suggesting to use it between cores at IXPs. And one thing that is important at this stage is IPGP next hop self. So that is the best current practice when your peer router receives an external route and announces it over IPGP to your other routers. You're supposed to set next hop self anyway, so that the next hop belongs to that router rather than the other member of the IXP. But with this change, with RFC 8950, the next hop will be an IPv6 address if you don't change it. And your other router in your IPGP mesh might not understand, might not support this. And then funny things will happen. Basically, traffic can get black holed if that happens, for example. Or, well, that is, I guess, the typical thing that will happen. And also, I mentioned that ICMP unreachables, so basically the trace route packets, they can be unpredictable on some platforms. So a lot of documentation says that if the router should be choosing a loopback interface address for those when you're using RFC 8950. But we've noticed that no, they don't necessarily. One Juniper software version, for example, seemed to be choosing a completely random interface. It wasn't the address of the ingress or the egress port. It was some other port, and it wasn't the loopback port. So there are still issues that need to be fixed in many implementations. Looking glass support, well, was near zero, but now Alice Looking Glass is at least working on it. So we've gotten that on their roadmap, which is nice. And, well, that's the gist of it. Do you have any questions?
So, yeah, the normal microphone is working again. So there's no questions online on Mentimeter, but are there questions in the audience? I do see some hands. Can we get some lights in the... Oh, there they are. Where is... Jochem is gone, so I'll run myself this time. So please stand up and state your name, please.
Hi, thank you. Michel Grijmans. Testing? Yes, okay.
Yes,
thank you. Michel Grijmans, Sincere Cloud, Curaçao. A question about compatibility. If you have one router that's supporting this new RFC and the other peers are dual stacked, as in they do IPv4 and IPv6 sessions, then the router supporting this of using this RFC will not be compatible with the routes over the normal v4 announcers, right? Because they would receive a next hop address, which is an IPv6 address. That would cause issues, right? So all routers will be needing, all routers on this IXP will need to be on this RFC level, or can it be? Can you mix it?
You can mix it, and well, what I saw in one case was that we had a router announcing routes to another router over IPGP, and we had forgotten the next hop self, so it was sending the next hop as an IPv6 address, but it had gotten weirdly mangled. So there are bugs related to this. But first of all, when you are setting up a BGP session using, or where you want to use RFC 8950, the routers will announce capabilities that state that they want to do this. And they will negotiate that capability. So in theory, the router announcing a route with an IPv6 next hop, it shouldn't be announcing it over the session if the capability hasn't been negotiated. In practice, I've noticed that it might still do that. It's not a direct answer to your question, but does it help, or do you have a? Do you want to narrow the question?
Yeah, I was just thinking about it. So if you have multiple peers, one peer that does support it, another peer that doesn't support this RFC, then the peer that has a normal dual stack, so V4 sessions and V6 sessions, frankly wouldn't be able to receive any of these V4 routes sent out by the new RFC router, which is only IPv6.
Yes.
Because they wouldn't be able to, well, assuming they have a V6 session, yeah, then we'll have funky issues.
So basically, they shouldn't be receiving them, and even if they would be receiving them, they shouldn't be accepting them. But I've seen a case where it still happened, but it was rejecting them because the mangled next hop was unreachable. So yeah, there are still some bugs related to that. And that's actually one thing that our working group is also, so if you go to the GitHub, we've written sort of a template of what each platform document should contain, what questions it should answer. And the basic ones were how to configure it, what version did the support come in, and so on. But at the end of it, there are things like, what does a trace route really look like? What happens if you've misconfigured either end, and stuff like that. And the MSc student hired by TREX will get to all of these questions later. First, they're just wanting to make the basic matrix, but then they'll start looking at these edge cases as well. But yeah, as you say, the unsupporting router shouldn't see those routes and shouldn't use them. But there might be bugs. There's another question.
Thank you very much. Oh, we have another question.
Do we have time?
I'll do the running around. I actually like it. It's too bad we find out at the end of day 2, but I don't mind.
Hi, Gregor Janoszka, Liberty Global. Maybe not a question, but a remark. When you change the exchange subnet, it doesn't have to be painful. The last links renumbering, it wasn't really a renumbering because you had to only change the net mask from /22 to /21. So there is no big pain in it. But yes, in most of the cases, you have to totally change the address, and that's very annoying.
Yeah, that's a good point. I remember that one version of my slide said that D6 in Frankfurt, they renumbered once in like the early 2000s, and since then they have changed the subnet mask 3 times. So they did the same thing, but earlier and on a bigger scale. So that is very true.
Okay. Are there any more? Oh, I see right away a hand on the other side. Sorry, you have to have a little bit of a walk. Stavros, please stand up. State your name and company, please.
Stavros, as a co-chair of the Router working group. Starting a new IXP with IPv6 only and RFC 8950 from scratch, I would say quite brave. How is the vendor support, however? How confident you are that members that will come with any kind of equipment will be able to support it, and we're going to have a good, smooth bootstrap of this XP? I remember you guys have had a nice table in the past with vendor support of this RFC because you did extensive...
it's on the GitHub, yeah.
So can you say some...
Yes.
Yeah.
So Juniper and Nokia, we've been testing those 2 platforms most because they seem, at least in our testing, they seem to have the most mature support for from the hardware side. Of course, Bird and FRR and so on, the open source platforms support it pretty widely. In addition to that, some Cisco software platforms like Cisco XR, I think, for example, supports it. Arista, I think, if I remember correctly, has supported it for quite a while as well. But there are some vendors where either we haven't found out if they support it or they don't support it. And two vendors which are for us, the sort of biggest problems right now are MikroTik and Huawei. Because a lot of smaller members, of course, will want to use MikroTik. And Huawei has said that they support it, but we haven't found config manuals. So we don't know if it really does. There are some platforms that have refused to take it on their roadmap, but I don't think those were important platforms, at least for us. But these two platforms are problems for us in Turku specifically because we've got one existing customer and one potential customer in Turku who are running these platforms. Also, one of our members in Tampere said that they'll connect to Turku, but they'll just exchange IPv6 prefixes at first because they are not sure if they are running the right software version on their routers yet.
Thank you very much.
Cool. Do we have more questions? We still have 3.5 minutes, so we can do another one. No, it seems like the audience.
Well, I could show a couple more slides.
It's the Junos ones, right?
Huh?
It's the Junos ones.
Yes.
The examples. Yes, please, go.
Yeah. So I just thought I'd give you an example of what it would look like. This is for an example config for our Turku exchange point. So the point here is, this is the interface config that you need to set up. And the point here is that you need to configure family inet, even if you don't have an IP address in it, because otherwise it won't forward IPv4 packets. And this is typical on many other platforms as well, that you have to somehow configure IPv4 on the interface, otherwise it won't process IPv4 packets, but you just omit the actual IP address. Yeah, what you also can do is you can set some random address, which is not associated with the subnet really. And Juniper, for example, in that case, will send the traceroute responses from that address. So that is how you can control what shows up on traceroute if you want. Then on the BGP session config side, you of course need to configure two families on your BGP session, or in this case it's for the whole group. And the highlighted extended next hop is the setting that changes the next hop from IPv4 to IPv6 in Junos. And then this is what it would look like if you were looking at a route that uses this system. So this is one of our members. The first two lines are from the new Turku exchange point. The third line is from the Tampere exchange point using a traditional BGP session, and the last line is our transit. So this is from the exchange point ASN router. So basically, it'll just show IPv6 addresses there instead of IPv4 addresses. If you go into more detail with show route, it'll show the next hop groups and stuff like that. And actually, speaking of next hop groups, one of the issues that can also be problematic when using this technology is that if you do have a mix of IPv6 and IPv4 next hops, on some platforms, ECMP won't work as you expect. So it'll only do ECMP with next hop of the same address family. So it'll only ECMP over all the IPv6 addresses or all the IPv4 addresses. And then you need to somehow configure which you need to have your metrics or priorities or whatever straight so that it picks the one with more next hop types, I guess I've used my time very efficiently.
Very efficiently, with 18 seconds to go. Aleksi, thank you very much for all this information. It was a pleasure. Thank you very much.
Thank you.
Ladies and gentlemen, Aleksi Suhonen.